All right, example 6 is going to be the same process as example 5. So take a moment to try it on your own, then press play to see the answer. So we're told to start off with x equals -3. So -3 we're going to put in our box. We're going to go through our synthetic, or you could use long division if you wanted to, with the x cubed plus x squared minus 5x minus 3. 1 times -3 is -3. 1 plus -3 is -2. -2 times the number in the box, which is -3, gives us a product of 6. -5 plus 6 is 1. And I did something wrong. You want to know how I know I did something wrong? Because when I do 1 times -3, I get -3, and that doesn't give me a remainder of 0. And if I do this correctly, I should get a remainder of 0. So let me do this again, and let's see what I did. Let's just try again. All right, 1 times -3 is -3. 1 plus -3 is -2. Oh, I know why this is not working out. Because I have a typo. This should say +3. Okay, so that is positive. So Mrs. Walker has a typo for example 6. It should say +3 on the end of that cubic function, not -3. Because that'll give us 6, then we get 1, and then we get -3, and now it works. All right, so I had the function typed wrong in the notes. So what we've just done is we've taken this cubic, we've divided it, we have coefficients 1, -2, and 1, which means we have the quadratic equation x squared minus 2x plus 1. The x equaling -3 part here is really coming from the binomial x plus 3. So I'm going to pull that down for my factored form. I'm then going to factor x squared minus 2x plus 1. What multiplies to 1 but adds to -2 is x minus 1 and x minus 1. The x plus 3 carries down and the equals 0. Solving each of those for x. The x minus 1s are both going to give me the same answer if x equals +1, but because I'm getting that twice, I know it's going to be a multiplicity of 2. And x plus 3 means I'm going to get an answer of x equals -3. And it's only happening once, so I get a multiplicity of 1. Remember, we originally had something that was cubic, right? The highest degree was 3. And notice that our multiplicities add to be 3. So that's just kind of a way to double check that you know you did it right, because our multiplicities add to be the degree of the original problem. All right, so that wraps up the very lengthy lesson of 3.5. But if you have any questions, please reach out to myself or Mr. Brasser. Thank you so much.